Assalamu alaikum. Today's topic is vectors. Acha, there is no need to rush to write down things because the detailed note will be given in the comment section. It will the link to the detailed note will be given in the descriptions. Sorry. Okay. So let's start vectors. Now, the very first question, what is vector? Now, any object, any quantity can be either a vector or a scalar. Now, a scalar is something that has only one magnitude and no direction at all. A scalar can act in different directions. One of the examples of scalar will be temperature, and I just use this part. Okay, examples of scalar can be temperature and then pressure and a lot more. And examples of a vector can be force, displacement, not distance, displacement. Okay, distance is a vector. Sorry, distance is a scalar, my mistake. And displacement is a vector. Speed is a scalar and velocity is a vector. Speed and velocity are basically the same thing, but when we give the speed a direction, it becomes velocity. And we know how displacement works. That is also a counterpart of distance and is a vector. Now, these are actually the quantities we use for what we call mechanics. Mechanics is basically the study of moving objects, and which is the basic of unit 1. So these are the quantities we use for mechanics. Now, to use these quantities or to work with these quantities, we need to know how our vectors are working. Otherwise, we won't be able to work with the mechanics. Okay. Now, one of the basic examples of this change in vector or how vector actually works is how we calculate resultant force. Okay, so here is an example. A 10 Newton force is being applied from the right and a 20 Newton force is being applied from the left. Now, the forces are opposite, and as the forces have different directions, we are assigning them with different signs to assign different directions. So we are assigning a positive for right and a negative for left. Now, if my resultant force is towards right, I could say the resultant is in plus and then the force and then the newtons. But when my force is towards the left, this is how I write it: negative of 10 and then newtons. That is my resultant force because 20 is a bigger force, and the vector sum or the vector or the difference of the vectors is my resultant force. It is called vector sum. The vector sum is the magnitude of resultant. Now, till this part, we understand how we find out our resultant forces and how the vector thing works. So now, when a vector is acting in a straight line, when a vector is acting horizontally or vertically, so in the calculations we use the full part of the vector, or we use the vector as it is. Like for example, if this is a 10 Newton vector, in the calculations we will be using a 10 Newton. A better way of describing this is if the vector is in the direction of motion. So if the vector is acting in the direction of motion, then we can say that the whole force is be acting in the direction of motion. Now, when we apply a force on an object, and the force, now this is the applied force, okay? Now it's not necessary that all the force we apply will be acting on the object. Let's say this blue line is the force acting. So now if my applied force is parallel to the direction of motion, the force acting on the object must be equal to the force applied. Might sound a bit confusing, so I'll write it down here. According to this definition, if the resultant force is parallel to the force applied, then the resultant force must be equal to the force applied, which means that if I apply the force at an angle, then the resultant force and the force applied will not be equal. We have discussed this detailed in the note, so if there is any confusion, please refer to the note. In the note, this has been written in a very clear statements. Even then, if anyone has any confusion, you can write it down in the comments, or you can ask me in the solution class. Now, if I take an object, and I apply a force at a direction, now let's say there is a horizontal table here on which the object is sitting. So if I apply a force in this direction, this force can in no means be directly applied on the table. There will be a bit of downward force that will be applied here on the table, but there will be no movement downwards. The movement has to be along the plane, right? So in this case, we have to resolve our vectors, or we have to divide our vectors into two parts. So if we resolve this vector, what we will find is we will find a horizontal and a vertical vector. Now, this vertical vector is the force being applied on this plane, on this table, on this plank, whatever it is. Now, now, but there is this vector acting along the plane or acting parallel to the plane that will cause this motion. That will cause this motion to happen. Now, if this is F, denoted as F, we can say that the force being applied, definitely it's at an angle, so there will be an angle acting here. Let's refer to that as theta. So we can say this is F cos theta, and in that case the force acting downward has to be F sine theta. Now, how to define cos, how to define sine, we'll work on that, but this is the main concept of how we resolve vectors. If a force is acting directly vertical or directly horizontal, we do not have to resolve it. But when a force is acting at an angle like this or somewhat like this, when we can see that there is an angle forming with the horizontal or with the vertical, like there can be a force like this, there is a angle with the vertical as well. So these kind of forces need to be resolved, and when we resolve them into two parts. A part of them is the horizontal and the other part of them is the vertical. Now, Here is another example. If my force is acting like this, then if the green is my actual force, that is denoted as U, and we try to resolve it, then we can resolve it in two ways. So I will first mask this out. For the time being, we are only concentrating on the green part. So if we work with the green, we can see there we have X and there we have Y. Okay, there we have X and there we have Y. Now if the green angle is theta, the way we actually resolve vectors is the angle is touching my resultant line and one of the component lines like this. The angle is being formed with this component line. So this component line is in touch with the angle. So the line it is touching will always be cos, and the line it is not touching, this is the line where we can see there is no link with the angle, that will always be sine. If we see the same thing using theta, we can see the theta is touching this line y and the u. So as the alpha line is touching my y, so the y line will have a cos alpha and it is not touching my. Now as this angle alpha does not have any connection with my line x, I can say my line x is u sine alpha because there is no connection with alpha. Now let's take a look at this separately. For example, if I have this line which is a vector and it definitely is has at an angle with some line, either a horizontal or a vertical. As you can see, I haven't connected the lines just for the example. So if this is acting along the if this is at an angle along with the horizontal, then I can say that there is an angle that is theta. Now if this is F, this is the force that is acting on an angle, as the theta is connecting these two lines, I can write this is F cos theta. And now if I take another line which is acting here and has no connection with the theta, I can write this as F sine theta. Now what if the whole case was vice versa? What if I did not have an angle here? What if the angle was right here and the theta was connecting my f and y and not f and x? In that scenario, just this thing will be replaced with cos, this thing will be replaced with sine. The reason is the theta is connecting these two lines. A very simple way of remembering this is with angle is cos theta and without angle is sine theta. This is a very convenient way of remembering this that helps us keep the track of how theta is working. Basically, when the angle is connecting two lines, the connecting line will be used as cos. The line which is being connected will be used as cos. So I think this is a good example of how vectors are working. Now we need to also learn how we find the resultant force of vectors. Now, there are two different types. One is the parallelogram method and the other is the triangle method. In the parallelogram method, we use two different lines. Now, here, as we can see, we have two different colors of lines. The black is basically the copied lines. Now, what is the copied lines? Yeah, we'll talk about it. Just give me a second for that. Let me just write how the colors are representing. The black in this is a copy of lines, and the blues are the real lines. Now, let's say I have two lines. One is this and the other is this. So I have to use these two lines to find a resultant. So what I can do is I can just place these lines beside each other, and after placing them I can copy these lines exactly. So a copy of this line will be this, and a copy of this line will be this black line. When we join all the lines there, we get a parallelogram. I think we can see the clear parallelogram, and from the parallelogram we'll see the arrows. Now, when we see arrows, we know where the resultant must be acting. As the arrows of these two lines are connecting here, which means the resultant must be acting here, and these two are pointing outwards. That means my resultant line must be somewhere here, which was initially marked as the green line, the resultant. Now, in a parallelogram method, we have to copy the lines and arrange them, so it is a bit time consuming. And there is this other method, that is the triangle method, where we will have to use our brain a bit and we will just see which line can be oriented in a way so that they form a partial triangle. Now, I can set these lines like this, and then I can draw resultant. In this case, if I draw a resultant, that will be something like this. It will be something like this, which is very similar to what I have drawn here. But if I do not do this, if I do it the other ways, if I take this line and connect it here, can I draw a resultant? Yes, I can. Something I did here. Okay, these were two possible combinations of the lines, but there are two other possible combinations of the line as well. Maybe I can place it here. Now if I place it here and I complete it like this, it is still a triangle, right? But as we can see, the angles are creating a loop. Now this is something we must remember, that when we are working with the triangle method, make sure the arrows do not form a loop at any cost. If the arrows are forming a loop, then that is not the right kind of triangle. Now, so this means as this is forming a loop, this is not the right kind of triangle. So this orientation isn't working. Apart from this, there are two other orientations, that is, one is like this and the other one is like this, and both they are working. And there is this fourth orientation in which it will again form a loop. So we can see that there are two orientations in which it is forming a loop and two orientations in which it is not forming a loop. So either we take this orientation, which is very similar to what I have drawn before, or we can take it in this orientation, which will be a mirror image of what we have on this side, which will be a mirror image to this, and but in both cases my resultant is the same, and this is my resultant. Now this is how we use a triangle method and how we use a parallelogram method. In the exam, using a triangle method is faster if we know how to use it. Okay, there are a few criteria of the triangle method. That is, first thing, no loop. Make sure it doesn't form a loop. And the second thing is that we have to make sure that a triangle has three pairs of heads. One head tail pair, which is basically this point right here, this point right here, where there is the head of an arrow and the tail of another arrow, or the tip tail method. Also, they also call it the tip to tail method. The head of an arrow is connecting to the tail of another arrow. One tail pair where the tail of two arrows are connecting, and one head pair where the heads of two arrows are connecting. If this criteria is met and it is not forming a loop, then we know that this line is the resultant. And this is a very easy way to find the resultant from two vector lines. And when we have the resultant, we can use component lines to sort the vectors. This is just a small example, and you can take a screenshot of this, and the detailed note is given in the description.